We've been talking about objects that are moving to the left and right, when we've used east as positive directions and west as negative directions. We talked about objects traveling at constant speed or velocity, and we've talked about objects that are accelerating. So now let's talk about a natural object that we experience all the time that's accelerating on Earth, and that is an object that's in free fall. But first, let's review our kinematics equations. So the last lecture we went over these kinematics equations. And we knew that we got a velocity equation function from our velocity graph for something that is accelerating. And we got our position function from a position graph for something that is accelerating, that's parabolic. And then we combined those two to come up with two others. So we did several different examples of problems, and we talked about where these came from, etc. Now let's talk about an object in free fall. By definition, an object in free fall is something that's just falling due to gravity. In these problems, we're not going to worry about an object that is experiencing any appreciable air resistance or friction. The only thing is gravity is pulling down on it. So imagine a ball, and there's a force of gravity acting on it. As it falls, it's going to pick up speed by the same amount every second. If we were to look at a ticker tape of it, it would be accelerating in the downward direction, and then it would have a negative acceleration because it's accelerating down to the south. The person that figured this out was Galileo. To give you perspective, he was born in 1564 and he died in 1642. He was really the first person to come up with this value of acceleration called the acceleration of gravity. Our symbol for it is g, little g, and it's equal to negative 9.8 meters per second every second. So as this object falls, it's going to pick up speed every second. So it starts with 0 speed, and then it has, after 1 second, a speed of negative 9.8 meters per second. And after 2 seconds, it's now negative 19.6 meters per second, and so forth. It's going to keep picking up its speed by the same amount every instant in time, assuming that there's no other forces acting on it. So it could be a ball that you've dropped, or it could be a ball that you've thrown down once it left your hand, or even a ball that you threw up. But we're just going to talk about things that fall from rest or balls that you drop, that you throw down. So let's look at the motion graphs to start with. You've already seen this one before, and this is an object that is experiencing free fall. The ticker tape shows an object whose dots are getting faster every second, so they're getting more spread apart every second. So the acceleration is in the negative direction. The position graph is a downward sloping parabola where its slope is getting more and more negative as it falls. Its velocity graph is a line with a slope of negative 10 meters per second squared. In this case, we're just rounding it up, 9.8 up to 10 to make it easy for us. And it has an acceleration graph that is flat, right at negative 10 meters per second every second. So for something that is falling, its position graph will be a downward sloping parabola. Its velocity graph is going to be a velocity graph with a slope equal to negative 9.8 meters per second squared. And its acceleration graph, it's going to be plotting at negative 9.8 meters per second squared, regardless of the mass that is falling, because the only force acting on it is gravity. So that means that this is an object that is accelerating. And we are going to have kinematics equations that are exactly the same as the ones we had before, but we may be using a little bit different variables. Our acceleration is always going to be g, which is always going to be negative 9.8 meters per second squared. And VF is going to be negative And our delta x is really a change in y and is negative when you fall down and positive if you rise up. So if we were to redo our equations, it would be VF equals VI plus GT. Delta Y equals VIT plus 1/2 GT squared. I'm going to put these little arrows over our arrows so we'll know which ones are vectors that we have to have negatives, positives for. VF squared equals VI squared plus 2G delta Y. And delta Y equals 1/2 of VI plus VF times T. So you don't really have to rewrite these equations as long as you remember that delta x is the height that you're falling or dropping, and that A is always going to be negative 9.8. Let's do a couple of examples. So let's say that we have a ball that's going to drop from a height of 200 meters. So it's going to drop negative 200 meters. Negative because it's falling. And actually, I'll tell you what I'll do is I will make this a little prettier. So it's going to fall 200 meters. And it's dropping. So VI is going to be 0. Delta Y is going to be negative 200 because it's falling. And we know nothing about T, and we know nothing about anything. We cannot say that VF is 0 because we want to know exactly what's going to happen to it right before it hits the ground, not when it hits the ground. And we also know that gravity is negative 9.8 meters per second squared. Nobody has to tell us that. So if we want to know how long it's in the air, we want to know T. So we need a formula that has no VF in it. So what formula is that? Which one has no VF? This is VF, this is VF, this is VF. This one does not have VF. So we're going to use delta Y equals VIT plus 1/2 GT squared. And we're going to solve this for T. Now what's going to be nice about it is that VIT is going to be 0 because VI is 0. So this is going to make it easy for us. It's going to be 1/2 GT squared. And T squared is going to be equal to, I multiply 2 by both sides and I divide both sides by G. 2 delta Y all over G. So that's going to be equal. So once again, I listed what I knew. I found my equation. I solved it algebraically. And now I'm going to solve it. So T squared equals 2 times negative 200 meters all over negative 9.8 meters per second squared. And then I'm going to take the square root of both sides to find my T. Remember when you take the square root that you have a positive or negative root. And first time we'll always take the positive root. So this is going to be negative 200 times 2 or negative 400 divided by negative 9.8. So if you forgot to put a negative in here for either of these, you would be trying to take the square root of a negative. So that should be a red flag to you that you dropped one of your signs. And if I take the square root of that, I get 6.388. And let's just round this to 3 sig digs. So 6.39 seconds. Now, the next thing I want to do is I want to figure out how fast it's traveling. So let me just erase this. All right. So now, instead of finding t, I want to know the VF. So I want to know VF, and I have no t and no, well, that's it, I have no t. Now you can say, well, Miss Knight, I just found t to be 6.39. Try not to use something that you've calculated, if at all possible. It's much better for you not to. So I need a formula that has VI, delta Y, G, and VF in it. The only formula that has all that is VF equals VI squared plus 2G delta Y. And I'm looking for VF. Well, it's already solved for that, so I don't have to do any algebra. I've done num 2 and 3. So VF squared is going to be equal to 0 squared plus 2 times negative 9.8 meters per second squared times negative 200 meters. Meters squared is seconds squared, and then I have to take the square root of all of that. Now, remember that when you take the square root of something, you can have a positive or negative root. So when I do this, I'm going to have negative 400 times negative 9.8. I'm going to take the square root of it, and that is going to be plus or minus 62.6 meters per second. Well, since this is going to be, if I were to draw a picture of what's going on, it starts out at 0, and then it's building its velocity until right before it hits the ground, right? So VF is going to be negative. So I want to use negative 62.6 meters per second as my final velocity. If I ask for the magnitude, I just want 62.6. But if I ask for the velocity, I want the negative as well. All right, let's do the same problem, but let's change it up. We're going to throw this ball down with an initial speed of 10 meters per second down. That's negative 10 meters per second. And it's going to be falling at negative 9.8 meters per second squared. And it's going to fall negative 200 meters, and we want to find time. So the only formula that we're going to use is delta x equals VIT plus 1/2 GT squared. So let's go ahead and start putting some numbers in here. And I'm not even solving for t yet, because you're going to find this can be harder to solve for it. I'm going to have negative 200 meters equals negative 10 meters per second times time plus 1/2 of negative 9.8 meters per second squared times time squared. Well, this is complicated. I'm going to drop the units right now just so that we can look at this a little more cleanly. Negative 200 equals negative 10t plus 1/2 of negative 9.8, which is negative 4.9 t squared. I cannot simply just solve for t here. This is a quadratic. So what do you do with a quadratic? You have to solve with a quadratic formula. So we had negative 200 equals negative 10t plus negative 4.9t squared. I'm going to get it into the quadratic form, where I'm going to put everything on one side. I'm going to put, it says something x squared plus something x plus something. So I'm going to add everything over to the left-hand side. I'm going to get 4.9t squared plus 10t minus 200 equals 0. So A is 4.9, B is 10, and C is negative 200. So now I can plug it into my formula for quadratic. Negative B is negative 10 plus or minus the square root of negative 10 squared. Positive 10 squared minus 4 times 4.9 times negative 200, all over 2 times 4.9. So I'm going to find, first let me find what's in the radical here. So if I do that, 10 squared is 100, minus parentheses 4 times 4.9 times negative 200 equals, so this turns into negative 10 plus or minus the square root of 4020 all over 9.8. Now, if I take the square root of 4020, I get 63.4. So what I'm going to want to do, I'm either going to want to add or subtract off that, right? So that I end up with a positive number. Well, if I subtract it off, it's going to be negative 10 minus 63 is going to be a negative number. So that's not going to be a solution. So what I want to do is I want to go negative 10 plus 63.4 all over 9.8. And if I do that, I'm going to get 53.4 divided by 9.8. 5.45 seconds. Now, what about finding VF? Will anything change? Let's look and see. So VF, I'm not going to use my time. What if I mess that up? I would mess up VF too. So I'm just going to use VF squared equals VI squared plus 2G delta Y. So VF squared equals negative 10 meters per second squared plus 2 times negative 9.8 meters per second squared times negative 200 meters. And then I'll have to take the square root of both sides once I find everything under the radical. And I'm going to choose the negative solution to that. So I'm going to get negative 10 squared is 100 plus 2 times negative 9.8 times negative 200 equals 4020. Take the square root of all that. I'm getting 63.4 meters per second in the down direction. So notice it is a little higher, right? And it is not 0.